Hey guys! Today we will be going over the LeetCode problem to sum. So this is going to be different than my other tutorial in that we'll be using dictionaries and higher advanced logic dealing with complements, which results in a fast runtime beating 99% of LeetCode. So we'll go over it first. Alright, we'll begin by reading the problem. Given an array of integers, return indices of the two numbers such that they add up to a specific target. So they'll be giving us a list and they'll be giving us a target, and we essentially just return the index of the two numbers in this list that add up to that target. They also tell us you may assume that each input would have exactly one solution and you may not use the same element twice. Alright, so we know that there won't be multiple solutions. Well, in this example, they give us this list and this target, and we can see that 2 and 7 add up to 9, so we would return a list containing 0 and 1. And today I will be coding in Python. Alright, so I have this over here, so we can copy this. So I'm going to copy this over. We don't need cell for now. And as you can see, I already have a main method written that I can use to test. So we'll get started. I also have the problem copied above for reference if any of you guys need to see. So this tutorial is going to go a bit faster in that I'm not going to explain everything I am doing until I finish coding, but I will just set up the nums list and the target so we can reference that. Alright, so I have this 2 here and I'll explain as we go. So first of all, in this function, I am going to set up a dictionary that I'm going to use. It's going to contain the complements, which I'll go into depth after. Now I'm going to iterate through all the index of this list. So for I in range length of nums. Alright, so essentially what this is doing is I am just assigning I as the index and I'm just iterating through. So we have 1, 2, and 3. Alright, there we go. Now what I'm going to do is I'm going to check if the value at that index, so for example, if the index was 0, the value would be 2, is already in the dictionary. Then I know the complement exists and I return it. And I'll explain more later. So I'm going to check if nums I is in complements. Then I return I, which contains the index, and I return the dictionary complements given nums I as the key. Alright. But if it's not in the dictionary, then I know its complement does not exist. So currently nothing adds up to the target. That's its complement. So I would add that to the dictionary. So what I'm going to do is I will add its complement. So target minus nums I, right? That would be the complement of 2 in order to get 9. So that would be 9 minus 2, which is 7. I add that as a key to the dictionary and I give it the value of I. Alright, now I know you might be a little bit confused, so we'll go over what's actually happening here. Alright, so you have a dictionary, right? So complements is the dictionary. It starts out as empty. So essentially what a dictionary is a container that maps a key to a value. So we're going to have things like key to value. So we'll just go through. So let's say this is the index. So this is what I is currently, right? 0, 1, 2, 3. So I have this, right? And these are the values. So right now we have 2, 7, 11, and 15. So these are the values, right? So I just mapped the index to the values here. And so what I'm doing is I'm iterating through this, and essentially what I'm doing is I'm checking if nums I is in complement. So let's say before I do that, here's my dictionary complements, right? So here, first iteration, let's go through it. So I run it and I see, okay, it's not in complements because right now complements is empty, right? So right now complements is empty. And what I do is I see it's not, so I skip over this. And then what I do is I calculate for the complement of this value, and then I put it in the dictionary. So what's the complement of 2? How I do this is I do target minus nums I. So what is target minus nums I? Target minus 2, 9 minus 2 is 7. So I have 7 as the key. Now I map that to the index. What is the index? It's 0. Okay, cool. So it ends like this. Next. Okay, next iteration I go in. Right now the index is 1 and the value is 7, right? All right, so we go in. What I do is I first calculate if nums I is in complement. So what is nums I? That's the value. Is the value in complements? Yes, it is. By checking if something is in a dictionary, you're checking for the key. So yes, I see that this is a key of complements. So then what I can do is I can just return. So where I can just go, so I check. So check 7 is in complements, right? So now what I do is I can just return the index held by the value in the dictionary. So I can return what 7 is holding, which is 0, because that's the index of where 7 is, right? So I return both I, which is currently 1, and what its complement is holding in the dictionary, which would be its index, and 0. So you can see that this is returned and this is correct. Just to check, we run it, and there we go, we get 1, 0. Okay, now I'm going to change some of the numbers and just run through another example. Here I changed some of the list values and the target to 6, and you can see 4 and 2 make up 6. Now I'm going to come up here and just change everything as well. Okay, there we go. Now I'm going to just come down here and I'll run it through with the new values so you can understand the concept and delete all of this. Okay, now I'm going to change the values to 3, 7, 4, and 2. Okay, cool. Now we're going to run through the loop. So for I in range length of nums, right now I is at index 0, the complements is an empty dictionary, and then we check if nums I, which is the value, which is 3, is in the complements dictionary, which is not, because right now complements is an empty dictionary. So we execute the else statement. So the key is target minus nums I, so that's 6 minus 3, which is going to be 3, and the value is the index, which is 0. Okay, so we'll copy that dictionary down and then run through the loop again. So for I in range of length of nums, now the index I is 1, and the value, which is nums I, will be 7. And then we check if it's in complements, it's not, so we're still going to skip to the else statement. And then we're going to do 6 minus 7, that's negative 1, mapped to the index, which is 1. Alright, now we'll copy down the dictionary again. Now we're going through the loop again for I in range of length of nums. Now index is 2, and the values nums I is 4. We checked if that's in the dictionary. No, it's not. It's not one of the keys. So what we're going to do is, again, we skip to the else statement, and again we do 6 minus 4, which would be 2, and then that maps to the index, which is also 2. Alright, so now we're going to copy that dictionary down over here. And now we're going to go through the loop again for I in range length nums. Now I is 3, so that means nums I, which is the value, is 2. Okay, so now we're going to check if nums I is in complements. So nums I right now is 2, and we can see that in the dictionary 2 is one of the keys. So I'll just write it out. What we do is check if 2 is in complements, and then afterwards we can return what the current index is, which is 3, as you can see, and then return in the dictionary what the 2 maps to, which is also 2. So here I would return 3 and 2, which is the correct answer. The reason why this algorithm is a lot faster is because it essentially has O of n runtime, because the worst runtime is just going through this entire list. But if you go down this entire list, by the end, you'll always reach an answer, because usually by the second complement you would have the answer, right? And that can't exceed the entire list. But the other method I taught in the other tutorial, that takes O of n square runtime. The reason being that each time you arrive at 1 in the list, you check to see if the rest is in the list. That could take up to O of n runtime. So for each of these, you're taking another n, so n times n, that's n squared. So now let us put this into LeetCode and compare it. Remember that when you're testing on LeetCode, you always have to add self if you move to somewhere else to compile it. Alright, so you can see that the runtime is definitely a lot faster, even though there's a trade-off on memory space, but that's why I created 2 videos for different types of runtime. But overall, this is a really great solution. This solution I thought was really cool because it used both the logic of complements and also a dictionary. If you have any questions about any Python functions and tools, feel free to ask below. And I also have this code uploaded to my Google Drive if you want to check that out. Okay, thanks for watching. Hope this helped. Bye.